progression. Consider the sequence 1, 5, 9, 13, 17 and so on. What is the speciality in this sequence? In this sequence, T2 minus T1 is 5 minus 1, which is 4. T3 minus T2 is 9 minus 5, which is 4. T4 minus T3 is 13 minus 9, which is 4, and so on. This means we get the difference between any two consecutive terms is constant, that is 4. Now, let us consider another sequence. 8, 5, 2, minus 1, minus 4, and so on. What is the speciality in this sequence? Here, T2 minus T1 is 5 minus 8, which is minus 3. T3 minus T2 is 2 minus 5, which is minus 3. T4 minus T3 is minus 1 minus 2, which is minus 3, and so on. This means in this sequence too, the difference between any two consecutive terms is constant, that is minus 3. Let us take one more sequence, 2, 2, 2, 2 and so on. Here again, the difference between any two consecutive terms is constant. That is, T2 minus T1 is 2 minus 2, which is 0. T3 minus T2 is 2 minus 2, which is 0. T4 minus T3 is 2 minus 2, which is 0, and so on. Such a type of sequence is called an arithmetic progression. So what is the condition necessary for the sequence to be an arithmetic progression? A necessary condition for a sequence to be an arithmetic progression is that the difference between any two consecutive terms should be constant. Thus, we can define arithmetic progression as arithmetic progression is a sequence in which difference between two consecutive terms is constant. In short, arithmetic progression can be called as AP. The common difference is denoted by D. Students, note that the common difference can be positive, negative, or 0. In the first example, the common difference was 4, that is positive. In the second example, the common difference was minus 3, that is negative. In the third example, the common difference was 0. In an AP, we know that T2 minus T1 is D. Therefore, T2 is equal to T1 plus D. T3 minus T2 is D. Therefore, T3 is equal to T2 plus D. T4 minus T3 is D. Therefore, T4 is equal to T3 plus D, and so on. Tn minus Tn minus 1 is equal to D. Therefore, Tn is equal to Tn minus 1 plus D. In general, we can say that in an AP, Tn minus Tn minus 1 is equal to D, that is constant. Conversely, the sequence is an AP if Tn minus Tn minus 1 is constant for all n belonging to natural numbers. Let us solve some examples based on AP. We have to find whether the given sequences are AP or not. We know that a sequence is an AP if the difference between any two consecutive terms is constant. Let us take the sequence one by one. The first sequence is 1, 4, 7, 10 and so on. In this sequence, the first term T1 is 1. The second term T2 is 4. The third term T3 is 7. The fourth term T4 is 10, and so on. What is T2 minus T1? T2 minus T1 is 4 minus 1, which is equal to 3. What is T3 minus T2? T3 minus T2 is 7 minus 4, which is equal to 3. What is T4 minus T3? T4 minus T3 is 10 minus 7, which is equal to 3. Here, the difference between any two consecutive terms is same. This means the common difference is 3. Therefore, the sequence 1, 4, 7, 10, and so on is an AP. In the second list of numbers, 3, 6, 12, 24, and so on, the first term T1 is 3. The second term T2 is 6. The third term T3 is 12. The fourth term T4 is 24, and so on. Here, T2 minus T1 is 6 minus 3, which is 3. T3 minus T2 is 12 minus 6, which is 6. T4 minus T3 is 24 minus 12, which is 12. Thus, the difference between the consecutive terms 3, 6, 12, and so on is not the same. Therefore, the given numbers is not an AP. In the third list of numbers, minus 10, minus 13, minus 16, minus 19, and so on, the first term T1 is minus 10. The second term T2 is minus 13. The third term T3 is minus 16. The fourth term T4 is minus 19, and so on. Here, T2 minus T1 is minus 13 minus of minus 10, which is minus 13 plus 10, which is minus 3. T3 minus T2 is minus 16 minus of minus 13, which is minus 16 plus 13, which is minus 3. T4 minus T3 is minus 19 minus of minus 16, which is minus 19 plus 16, which is minus 3. Since the difference between any two consecutive terms is the same, that is minus 3, the given numbers minus 10, minus 13, minus 16, minus 19, and so on is an AP. Write the first 5 terms of the AP when the common difference D is minus 3 and the first term is 10. It is given that the first term T1 is 10. We know that T2 is T1 plus D, which is 10 plus of minus 3, which is 7. T3 is T2 plus D, which is 7 plus of minus 3, which is 4. T4 is T3 plus D, which is 4 plus of minus 3, which is 1. T5 is T4 plus D, which is 1 plus of minus 3, which is minus 2. Therefore, the first 5 terms of the AP are 10, 7, 4, 1, and minus 2. General representation of an AP. We have learned that an AP is a sequence in which difference between two consecutive terms is constant. We will now see how to write AP by using the first term and the common difference. We know that the sequence 1, 4, 7, 10, and so on is an AP with 3 as a common difference D. In this sequence, the first term T1 is given as 1. Let us denote the first term as A. Therefore, we can write T1 is equal to 1 is equal to A. How do you write the second term 4 by using the first term? The second term 4 can be written as 1 plus 3, which is nothing but A plus D. How do you write the third term 7 by using the first term? The third term 7 is equal to 1 plus 6. It can also be written as 1 plus 2 into 3, which is nothing but A plus 2D. Similarly, we can write the fourth term 10 as 1 plus 9. This is same as 1 plus 3 into 3, which is nothing but A plus 3D. Therefore, we get T1 is equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, T4 is equal to A plus 3D, and so on. Thus, an AP can be expressed as A plus D, A plus 2D, A plus 3D, and so on, where A is the first term and D is the common difference. This is known as the general form of an AP. Hence, an AP can be formed by using its general form if the first term A and the common difference D is given. Let us now solve an example. Write the first 5 terms of an AP whose first term A is 5 and the common difference D is 2. The general form of an AP is A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. We know that T1 is equal to A and it is given as 5. T2 is equal to A plus D, which is equal to 5 plus 2, which is equal to 7. T3 is equal to A plus 2D, which is equal to 5 plus 2 into 2, which is equal to 9. T4 is equal to A plus 3D, which is equal to 5 plus 3 into 2, which is equal to 11. And T5 is equal to A plus 4D, which is equal to 5 plus 4 into 2, which is equal to 13. Thus, the first 5 terms of an AP with first term 5 and the common difference 2 are 5, 7, 9, 11, and 13. General term of an AP. We know that the general term of a sequence is its nth term Tn. In the same way, the general term of an AP is also its nth term Tn. We know the general form of an AP is A plus D, A plus 2D, A plus 3D, and so on. Therefore, T1 is equal to A. T2 is A plus D. This can also be written as A plus 2 minus 1 into D. T3 is A plus 2D, which can also be written as A plus 3 minus 1 into D. T4 is A plus 3D, which can be written as A plus 4 minus 1 into D. In the same manner, how can you write T5? T5 can be written as A plus 5 minus 1 into D. Now, what will be Tn? Tn should be A plus n minus 1 into D. Tn is equal to A plus n minus 1 into D is the formula for the general term of an AP. We will now derive the formula Tn is equal to a plus n minus 1 into d. Consider the general form of an AP. A plus d, a plus 2d, a plus 3d and so on. T1 is equal to a. What is T2 minus T1? T2 minus T1 is a plus d minus a, which is equal to d. Since it's an AP, the difference between any two consecutive terms must be same. Therefore, T3 minus T2 is equal to d. T4 minus T3 is equal to d, and so on. What is the term before the n minus 1th term? The term before the n minus 1th term is the n minus 2th term, that is, Tn minus 2. What is Tn minus 1 minus Tn minus 2? Tn minus 1 minus Tn minus 2 is equal to d. What is Tn minus Tn minus 1? Tn minus Tn minus 1 is also d. Here we have n a number of equations. Adding all the n equations we get T1 plus T2 minus T1 plus T3 minus T2 plus T4 minus T3 plus so on up till plus Tn minus 1 minus Tn minus 2 plus Tn minus Tn minus 1 is equal to a plus d plus so on up till plus d. What is the sum of all the d in the right side of the equation? It is n minus 1 times d. The right side is a plus n minus 1 into d. By cancelling the common terms, what will you get in the left-hand side? We get only Tn. Therefore, Tn is a plus n minus 1 into d. Thus, the nth term of an AP with the first term a and the common difference d is Tn is a plus n minus 1 into d. We can find any term of an AP by substituting the value of n in this formula. Let us solve a few examples by using the formula Tn is equal to a plus n minus 1 into d. Find the 25th term of the AP 12, 16, 20, 24 and so on. First, we have to find d from the AP. It is given that the first term T1 is equal to a is equal to 12. The second term T2 is 16. The third term T3 is 20. The fourth term T4 is 24 and so on. Therefore, the common difference d is T2 minus T1, which is 16 minus 12, which is 4. We know that Tn is a plus n minus 1 into d. Substituting n is 25, a is 12 and d is 4, we get T25 is 12 plus 25 minus 1 into 4. On simplifying, we get T25 is 108. Therefore, the 25th term of the given AP is 108. Let us solve another example. Find Tn for an arithmetic progression where T3 is 22 and T17 is minus 20. We know that Tn is a plus n minus 1 into d. Therefore, T3 is a plus 3 minus 1 into d, which is equal to a plus 2d. But it is given that T3 is 22. Therefore, A plus 2D is equal to 22. Let us denote it as equation 1. Now, T17 is A plus 17 minus 1 into D, which is equal to A plus 16D. It is given that T17 is minus 20. Therefore, A plus 16D is minus 20. Let us denote it as equation 2. By solving these two equations, we can find the value of A and D. Subtracting A plus 2D is equal to 22 from A plus 16D is equal to minus 20, we get 14D is equal to minus 42. Therefore, D is minus 3. Substituting D is minus 3 in A plus 2D is equal to 22, we get A is 28. Thus, we have found the values of A and D. We can get Tn by substituting A is 28 and D is minus 3 in the formula Tn is A plus n minus 1 into D. Therefore, Tn is 28 plus n minus 1 into minus 3, which is equal to 28 minus 3n plus 3, which is equal to minus 3n plus 31. Therefore, Tn is minus 3n plus 31. Let us solve one more question. How many 3-digit numbers are divisible by 4? In this question, we have to find the number of 3-digit numbers which are divisible by 4. That means we have to find the value of n. The 3-digit numbers which are divisible by 4 are 100, 104, 108 and so on up to 996. Here the first term T1 is A is equal to 100. T2 is 104. T3 is 108 and so on till Tn is 996. We have to first check whether the given sequence is an AP. Here, T2 minus T1 is 4, T3 minus T2 is 4, and so on. The difference between any two consecutive terms is the same. Therefore, the given sequence is an AP. Now, the first term A is 100. The common difference D is 4, and Tn is 996. We have to find the value of n. To find the value of n, we will use the formula Tn is A plus n minus 1 into D. Substituting the given values, we get 996 is equal to 100 plus n minus 1 into 4, which is 100 plus 4n minus 4. On simplifying, we get n is 225. Therefore, there are 225 3-digit numbers which are divisible by 4. Let us now learn how to find the sum of the first n terms of an AP. First, let us consider the positive integers from 1 to 10. How do we find the sum of these numbers? To find the sum, we add all the numbers from 1 to 10. The sum of the integers from 1 to 10, S, is 1 plus 2 plus 3 and so on up till plus 10, which is 55. There is an easy method to find the sum of these numbers. First we write S is 1 plus 2 plus 3 plus so on up till plus 9 plus 10. Now we write the same sum in the reverse order. That is, S is 10 plus 9 plus so on up till plus 2 plus 1. When we add both the equations, we get 2S is equal to 11 plus 11 and so on up till plus 11 10 times. Therefore, 2S is 11 into 10, which is 110. Therefore, S is equal to 55. This method was found by Johann Carl Friedrich Gauss, who was a German mathematician, astronomer, and physicist. He was the first to prove the fundamental theorem of algebra. He used the simple method to find the sum of all positive integers from 1 to 100. The method he used is as shown here. S is equal to 1 plus 2 plus 3 and so on up till plus 100. This can also be written in the reverse order as S is equal to 100 plus 99 plus 98 plus so on up till plus 1. Adding both the equations, we get 2S is equal to 101 plus 101 plus 101 and so on up to 100 times. Therefore, 2S is 101 multiplied by 100. Therefore, 2S is equal to 10,100. Therefore, S is equal to 5,050. By using Gauss's technique, we will now derive the formula to find the sum of the first n terms of an AP. Consider an AP A plus D, A plus 2D and so on, where A is the first term and D is a common difference. We know that the nth term Tn is A plus n minus 1 into D. What is the sum of the first n terms of the given AP? The sum of the first n terms of the AP is Sn is A plus D plus A plus 2D and so on up till plus A plus n minus 2 into D plus A plus n minus 1 into D. As per Gauss's technique, writing the sum in the reverse order, we get Sn is A plus n minus 1 into D plus A plus n minus 2 into D and so on up till plus A plus D plus A. Adding both the equations, we get 2Sn is A plus n minus 1 into D plus A plus D plus A plus n minus 2 into D and so on up till plus A plus n minus 2 into D plus A plus D plus A plus n minus 1 into D plus A. Therefore, 2Sn is 2A plus n minus 1 into D plus 2A plus n minus 1 into D and so on up till plus 2A plus n minus 1 into D n times. Therefore, 2Sn is n into 2A plus n minus 1 into D. Dividing by 2 on both the sides, we get Sn is n upon 2 into 2A plus n minus 1 into D. Thus, the formula for the sum of the first n terms of an AP with first term A and the common difference D is Sn is n upon 2 into 2a plus n minus 1 into d. By splitting 2a as a plus a, the above equation becomes Sn is n upon 2 into a plus n minus 1 into d. Since the first term t1 is a and the nth term tn is a plus n minus 1 into d, we get Sn is n upon 2 into t1 plus tn. This can also be written as Sn is n upon 2 into a plus l, where a is the first term and l is the last term. Let us now solve a few problems by using the formula for Sn. Find the sum of the first n natural numbers and hence find the sum of the first 20 natural numbers. First, let us find the sum of the first n natural numbers. We know that Sn is n upon 2 into 2a plus n minus 1 into d. Since the natural numbers are 1, 2, 3, 4 and so on, a is 1 and d is 1. Substituting the values of a and d in the formula, we get Sn is n upon 2 into 2 into 1 plus n minus 1 into 1, which is equal to n upon 2 into 2 plus n minus 1. Therefore, the sum of the first n natural numbers Sn is n into n plus 1 upon 2. To find the sum of the first 20 natural numbers, we have to substitute n is 20 in this result. Therefore, S20 is 20 upon 2 into 20 plus 1, which is 10 into 21, which is 210. Therefore, the sum of the first 20 natural numbers is 210. We will now solve one more question. Find the sum of all odd natural numbers from 1 to 150. Odd natural numbers from 1 to 150 are 1, 3, 5, 7 and so on up till 149. Here T1 is 1, T2 is 3, T3 is 5 and so on. The last term Tn is 149. T2 minus T1 is 3 minus 1, which is 2. T3 minus T2 is 5 minus 3, which is 2. T4 minus T3 is 7 minus 5, which is 2, and so on. Therefore, the sequence 1, 3, 5, 7 and so on till 149 is an AP. Therefore, A is T1 is 1, D is 2, and Tn is 149. First, we will find the value of n by using the formula Tn is a plus n minus 1 into d. Substituting the values of a, d and Tn in the formula, we get 149 is 1 plus n minus 1 into 2. Therefore, 149 is 1 plus 2n minus 2. On simplifying, we get n is 75. Since we know T1 and Tn, we can use the formula Sn is n upon 2 into T1 plus Tn to find Sn. Substituting the values of n, T1 and Tn in the formula, we get S75 is 75 upon 2 into 1 plus 149. On simplifying, we get Sn is equal to 5,625. Therefore, the sum of all odd natural numbers from 1 to 150 is 5,625. Let us solve one more problem. The sum of the first 55 terms of an AP is 3,300. Find the 28th term. It is given that S55 is 3,300. We have to find T28. We know the formula Sn is n upon 2 into 2a plus n minus 1 into d. When n is 55, S55 is 55 upon 2 into 2a plus 55 minus 1 into d, which is 55 upon 2 into 2a plus 54d. Substituting the given value of S55, we get 3,300 is 55 upon 2 into 2a plus 54d. Therefore, 3,300 into 2 upon 55 is equal to 2a plus 54d. On simplifying, we get 2a plus 54d is 120. Dividing throughout by 2, we get a plus 27d is 60. To find the 20th term T28, we have to substitute n is 28 in the formula Tn is a plus n minus 1 into d. We get T28 is a plus 28 minus 1 into d, which is a plus 27d. Now, T28 is a plus 27d and a plus 27d is 60. Therefore, T28 is 60. That is, the 28th term of the AP is 60.